Welcome to ASRG Worldwide Webinars, bringing you the latest in automotive security research, innovation, and education. My name is John Heldreth. I'm the founder of Automotive Security Research Group. Today is the 28th of January, and we're streaming to you live from Stuttgart, Germany. First of all, I'd really like to introduce myself again because no one could hear me before. So, as I said, my name is John Heldreth. I am the founder of ASRG, or Automotive Security Research Group. I have worked in the automotive industry for the last 15 years and now focus my time on product or vehicle security. I'm originally from Detroit, Michigan, in the US of A, but today I'm living in Germany and working at Porsche Engineering. Today, I also have with me Sven Schran. Sven, would you like to introduce yourself?
Yes, sure. So welcome everyone, wherever you are joining us, and I hope you will also enjoy our presentation today. So my name is Sven Schran. I'm working for the Robert Bosch GmbH, one of the biggest automotive supplier in the world, as product security officer. And together with RSRG, I am the coordinator of our European locations.
Great, Sven. Thank you for being here tonight with us. Just quickly, I would like to give a short overview of what ASRG is. ASRG is a nonprofit organization focused on the advancement of the automotive security industry. This is a community to support the coming together of two areas of competencies: the IT security market and the automotive market. This is a community for you, for the automotive engineer, for the IT security specialist, the beginner, the hobbyist, even for the people that don't even know what automotive security really means. This is a community of volunteers. Our entire organization is built on the volunteer efforts of the administrative team and, of course, people like yourself. We're trying to remove the boundaries that can occur in the automotive security industry. This could be communication, physical borders, finding ways to learn, finding different solutions, ultimately making good decisions because at the end of the day, we all have the same goals: to keep our customers, our families, our friends' data safe and secure, which can only be achieved together. If you want to get more involved, make an impact on the industry, start your own ASRG location, participate maybe in a technical committee, be a part of a project, please reach out to us. You can find out more information about ASRG at www.asrg.io or send us an email at hello@asrg.io. So, we we have now 6,000 members around the world, which is very impressive. And I'm really uh, happy about this because it really means that I think the values that we're bringing in ASRG are interesting for people, and that's what people need. So we have now 6,000 members, which is a huge milestone for us. We have 38 locations worldwide and over in 20 countries. If you don't see a location here near you, that's okay. ASRG is always looking to expand, not because we need the numbers or something, but because maybe it makes sense that people around you also are interested in automotive security, to hacking cars or to doing secure development, whatever it might be. There is people around you that might want to get together and do the same thing. And that's how all of these ASRG locations started. We didn't push out ASRG locations. Each one of these locations is a result of someone contacting ASRG and asking if they could start an ASRG in their hometown. So, really great things going on here. Glad to see such great participation from around the world. So please keep it up. If you are interested in starting an ASRG, please reach out to us again at hello@asrg.io. We have such good webinars coming up. So in February, February 4th, we have post quantum cryptography for all you cryptography lovers, standardization and using it in an automotive case study. Dr. Popelman will be joining us from Infineon, so check back next week for this great talk. On February 16th, 2 weeks later, speeding up vehicle vulnerability management with context based analysis. This is Guy Gillum. He's going to be joining us from Cybellum. Actually, I have a little bit more information about Cybellum coming up here in a few minutes. February 18th, voiding trust, real world trusted execution environment attacks. TEEs are critical for us in embedded systems to make sure we have a great anchor. We're going to have Christof Ferrario, Muna, and Nick Trimmers from Realize. They're going to be talking about TEEs and the attacks there. The 23rd of February, Thomas Liefert from Keysight Technologies is going to be joining us. The title is not yet fixed and released. It will be soon, I promise. Check back soon to asrg.io to see what's coming. February 25th, redefining cybersecurity for the third screen. From safety to privacy, Andrea Amico from Privacy for Cars. Great talks here. And these talks don't come from us. We only coordinate these things. So if you have ideas about good presentations or interesting information, or you want to share something yourself, get in touch with us. Write us an email, cfp@asrg.io. All right. So, as you guys all know, ASRG is driving security innovation and making available the resources needed to ensure good security implementations. One of the most important topics during the development of an ECU, a system, or a vehicle is understanding which vulnerabilities are existing. We, as developers, as testers, attacks, hackers, or hobbyists who are members of ASRG can make sure to fix, close, and solve the existing security vulnerabilities before an issue or a recall or even worse, a safety issue comes up. And at ASRG, we thought this was the utmost important that we have for the members a vulnerability management system where we have access to it, that the right people have the right access needed to get all this information. So we were searching around for someone to partner with. And I'm not sure if you guys saw or not, but we had an announcement last week together with Cybellum. So Cybellum is a company in Tel Aviv, and they are producing automotive security vulnerability management systems. And we looked around in the industry a lot for some of the best companies that provide these, and Cybellum was there, and we had long discussions about how Cybellum can bring to ASRG the Automotive Security Vulnerability Management Program. And this is going to be the future of ASRG. What we're talking about here is an open, free vulnerability management available to all the members. Okay. And it's going to be one of these things where we have this partnership, this great partnership with Cybellum, the experts in vulnerability management, ASRG, and you guys, because actually it's really important that we all have this ability to disclose vulnerabilities. We also need to understand what's going on in the field. So, anyways, I mean, I can talk about this all night. Vulnerability management is coming to ASRG. Cybellum is sponsoring it. It's going to be great. Check back soon. However, we need your support here. So we put together a small survey. It is small, I promise. The survey is trying to understand what is needed. What do we need to bring to ASRG, to the members, to make sure that you guys have the information that you need to make good decisions about development, to understand what vulnerabilities are out there. So take a few minutes, go to the survey, fill it out, and this information is going to help us shape the project that's going to come to you later. So I would really appreciate check it out, participate. It's really going to help everybody, I think, in the long run. All right. So before we jump into the presentation, if you do have questions during the presentation, please add them in the chat window and we will ask Dr. Ebert at the end. But now I have the unique pleasure of introducing to you Dr. Christof Ebert, or as I know him, Christof from Vektor Consulting Services. Christof, thank you very much for being here today. We're really looking forward to what you've brought with you.
Thanks, John, and thanks for your kind introduction. My name is Christof Ebert. I'm very glad to be today with ASRG. We have already participated as attendees in many of the streams which you had, and I think it's a real great organization what you had set up to bring together security experts in the automotive domain around the world. I appreciate very much that I have the chance to today present a little bit about security testing. The presentation will be looking into some techniques, and given the short time of any such webinar, what I try is to rather dig into one topic, which is, let's say, kind of hot, rather than going superficially across all. So after the overview, I will give more insight into what we call gray box pen test, which is a penetration test that navigates along the thin line between black and white box. That's why we chose the color gray, meaning that we take a little bit inside as much as we can get and optimize the pen test for more efficiency. Also, I will talk a little bit about full lifecycle support, because that's now getting really important, not only because of the R155 cybersecurity management system of UNECE, but we have the 21434. We have a lot of requests now to ensure that software and the updates are protected. That being said, very briefly on Vektor, those of you who are in the automotive, which I guess should be pretty much all, might have already heard about us. Vektor is a tier 2, tier 3 supplier in terms of tools like test tools and also software like AutoSAR. We're a market leader in the AutoSAR worldwide, and for that reason have quite a long history also in cybersecurity and functional safety, because that's what we also sell in our products. My responsibility is in consulting, worldwide consulting services. We have 4 topics in our consulting portfolio. That is transformation, such as agile, SPICE, etc. Trust, which is our topic for this evening, safety, cybersecurity, and related methods and tools. The topic of technology, which is increasingly relevant as companies now understand to have good architecture, understanding, lifecycle support, AutoSAR introduction, or any other base software, and certainly also the necessary technologies for cybersecurity. And finally, trainings, which are like security trainings, etc. I jump ahead into what is a relevant topic, and I thought before we really talk only about security, one thing which I just have very fresh in front of me is our recent customer survey, which we had just finished at year end, and in the meantime also analyzed, which is what we call the trends and we do that on an annual basis. We put horizontally short-term challenge, vertically long-term challenges. One interesting thing here is that innovation is at the very top, which is new. Last year we had in the very top quality, cost, competence. And the reasons are pretty similar to, if you think about it, which is a year earlier, we just had all this global uncertainties about what's going to come and big pressure on competitiveness. And after 1 year, we realize what started out in the past year with COVID-19, as it was called, is maybe with different names, but certainly something which is not disappearing fast. And for that reason, we have to continue along topics which we really care, and that's innovation, because we cannot just now stop everything, even if there are constraints which are not the easiest, but still we have huge obligations in terms of ecologic driving, in terms of the transition, which John just mentioned, what we call the convergence of product IT, which is embedded, and business IT, which is all the cloud services. So there are many things to come, and we need to deliver. And that's why innovation appears suddenly on the upper right corner, which makes me very happy, because it shows that companies have realized that there is a light at the end of the tunnel. Maybe the tunnel is long, but we have light also inside the tunnel, and this is even more important. So very important that we think optimistic into this year, even if there are stormy waters. That's unpredictable. There will be not this push button cure, but certainly we will have a good future in front of us. And this is what I think is a major message here. Now, one of the topics which drive is what is called industry ACEs, autonomy, connectivity, ecology, and services. And the impacts on the business, of course, are manifold. I will not go now into these details, but what I want to emphasize is the last bullet here, which is that we have fast-growing liability risks, specifically with cybersecurity, and that we have to master those. In all of these technology challenges, I mean, I mentioned the convergent. We have SOA appearing now very fast with AUTOSAR Adaptive and similar. We have new challenges with AI, as we have to consider SOTIF, for instance, which, by the way, also impacts cybersecurity, because we suddenly have now situations where we have multi-sensor, not only fusion, but also confusion. And these are things which we currently deal very seriously from a security perspective, because there are always more than enough bad guys out there who want now to obscure sensor information from the outside. We have, of course, agility, which is going to stay and helped a lot in the past years in terms of competitiveness. And we have continuous X, which is, of course, known to all of you. The attacks in terms of security are increasing fast. What we see here on the right side is the evolution, if I may say so, because it's in fact almost looking like one of these charts which we see every evening about the COVID-19 spread, but I'm going to stop this energy now. But I mean, it's an exponential increase. That's the short message. And it will very fast increase. Why? Very simply because of connectivity. I mean, IoT brings with it that we have lots of open interface. We move a vehicle more and more into Ethernet. We go away from classic protocols where there were not so much tools available for hacking. I mean, Vektor had been around for all the time with all these networks. And what we see currently is, of course, a kind of more and more use of standardized protocols, which is definitely more cost effective. Standards are always good, but it also means that there are much more tools available to hack these systems. And that means even if the attack points are pretty much similar over the years, key fob server, smartphone, the diagnostics interfaces, and the, of course, infotainment, we still also see that the amount of hacking is fast increasing. And that's what we have to worry. We will have more cyber attacks, and we have to prepare now to mitigate these risks. And this is exactly what I want to emphasize also in this presentation. Because one thing is the left side of the V, where we look into the risks and the threats and how to mitigate. The other side is the right side of the V. And that is what we have to do very efficiently and effectively. And that would be the major content of my presentation. So we see many ways to attack, and I'm not going to explain all of those. Again, you are experts, so I don't have even, but we have all these possibilities to attack in a connected world. And that means we face an increasing move in terms of liability risk away from mere electronics like 10 years ago, functional safety like 5 years ago, into cybersecurity, which, by the way, of course, impacts also functional safety. And what we know from IT, which is also my background, when I started my professional career, I started out in ICT, and I learned very early about attacks. In fact, even during my studies, I already was confronted with it, and I thought we have to work on architectures, we have to work on hardening, continuously hardening, because security is one of these things which are a system attribute, not something which you can design after the facts. And a lot of these gaps are detected by third parties. That's an IT normal, but it will also be normal in automotive. And that's, by the way, exactly why we need over the air, because we cannot protect ECUs, we cannot protect complex IT systems like a car if you're not able to provide patches and cures in a very fast time frame, because zero-day exploitation in IT is known to be in the minute time frame. As soon as things are known, they will be exploited, and that will happen to the cars equally. Now, of course, we also have the situation that, unlike IT systems, in most domains, we here have high safety risk. And that means, since we all know that there is no safety without cybersecurity, cybersecurity is the precondition of functional safety. And any one of you who works in the 26262 functional safety domain knows that one of the first assets is always the high ASIL level safety goals. I mean, this is just but one thing which we have to focus on. There's much more, and for that reason, we also have a growing amount of standards. And they tend to be overwhelming because we have continuously new standards. If you rewind a little bit, when we go backwards in the, let's say, 15 years ago, we had just the 26262 appearing in its initial definition, was all the standardization activities until it was finally released. Then we saw a steady evolution with functional safety until we realized we need now really specific cybersecurity standards like the 3061, the 21434, which came out more recently. We had, of course, a lot of IT security standards. We have several standards which are not even mentioned here, like the 25000 series, which is about quality requirements. And we had last year a very fast growing awareness of the R155, which is CSMS, and R156, which is SAMS, and all that relate to homologation. And if we now just look to today, all of that is now overlaid with automatic driving. So we have in safety, for instance, at 21448 for SOTIF. We have also standards appearing right now with respect to how can we harden the autonomous driving. And literally this afternoon, I got on my table a bunch of brand new regulations here in Germany. So, of course, other countries would have other timeframes, but Germany normally in these things is rather early. So there's a whole stack of standards which now try to govern how to harden autonomous systems in order to make them ready for homologation. In other words, the amount of standards is very fast increasing, and any of these released standards and laws is a topic of liability, because product liability means that you deliver your product following the state of the practice, and the state of the practice are released standards. So that's why I show this chart, because it's not to create complexity. It's just there, and we have to follow, and we have to do that efficiently. And this is what I see with many of my customers, that we see lots of redundancies. I mean, I see even with some OEMs situations where we have one pillar for safety, one pillar for security, which of course creates high redundancies, if not even ping pong effects. And we, in order to manage these standards, we have to very carefully look into how much reuse we can achieve, how much cross-fertilization we can achieve. And this is one of the topics where I work quite hard to make sure we can satisfy the standards from a compliance perspective, but at the same time, don't, let's say, get into the treadmill that we only, let's say, deliver documents and don't anymore are able to innovate, because this needs to be balanced. Now, moving on into the technical part, we have in this security standards, notably 21434, but it applies equally to the IT security standards, medical security, etc. Always the approach that we have the TARA, threat analysis, risk analysis, which we then link into security requirements, architecture, implementation, and test. And here comes now the major message, which is this thin lines in between, which is we need traceability. So the most important word here on this slide is really the word traceability. If I was asked 10 years ago, what is a major problem in or challenge in most of software development in vehicles, I would have said it's requirements engineering, it's config management, it's traceability, it's project management. This is my top 4. Unfortunately, 10 years later, it's still my top 4. Just the positioning is a little bit changing. We still have requirements engineering first, but we have traceability second. And this is my real pain. And I see many companies, and I look into many repositories, ALM, PLM, and so on. And I hardly see horizontal traceability, which is on a sufficient level. Sometimes I'm even wondering how would they really achieve a high ASPICE level, because you see so much weakness in traceability that sometimes you're really afraid. Where it's working is in functional safety, because this is highly governed. But as soon as you move slightly outside, you look to quote, quote, normal functions, then we have these challenges with lack of traceability. And lack of traceability normally means inconsistencies. Inconsistency means that you cannot really do the right regression strategy. And that occasionally leads into not only defects, but also vulnerabilities, which are not really necessary. Now, in order to cure, we have started out to think very carefully about how can we make the traceability more formal. And this is now a summary that looks a little bit, let's say, heavy on the first view, even with the different colors. But there's 2 major topics here. One, we use something which we call a triple peak model. Most of you know the twin peak, which is requirements and design, where you start at the upper left, the requirements the market needs. You move to the design. With the impact analysis, you realize a couple of impacts and open questions. You move back to requirements, you clarify these things. So you go back and forth and you go downwards towards the more hands-on implementation. That's the twin peak model, which has been developed about 15 years ago as a very nice analogy. We have added over the past years third peak, understanding that test is absolutely critical and rarely considered in this context. And that's why we speak about triple peak instead of twin peak. The story is the same, except that we move not only into design, but also into test. Why? Because we need, not only because of security, but security is the real trigger point. We need to think in test cases. We need to understand our requirements in a testable way. We have to put negative requirements. I mean, this is a whole new discipline, which in security or safety is, of course, highly necessary. It's also necessary from a user experience perspective that you treat misuse cases, abuse cases, and confuse cases. But so far, they were not really integrated in your normal requirement scheme. So the important part here is, that's the second thing which I want to emphasize, that we need test-driven requirements engineering in the best possible case. You always start out with a requirement. I mean, you all know that from test-driven development. It's just bizarre that test-driven development took so long to ramp up into the topic of design and architecture and systems engineering. But with increasing usage of MBSE, which is model-based systems engineering, we will also see that what you just have in front of you becomes state of the practice. I teach it in the meantime to my students because, you know, you always to start in the beginning. Cannot expect that seasoned engineers would immediately buy all that. But from a student perspective, it's much more natural to see that test is part of requirements engineering. And that is what I want to get across with this picture, that we have this forward test-driven requirements engineering. That means that we analyze requirements from a design perspective, create a test case, and backward, that with the test cases, even in the initial testing, we see gaps, we see problems, we see weakness, and we try to do that as early as possible to enrich our requirements in terms of testability. But also, and this is now the commercial aspect here, because I mean, whatever you're doing, we should always be very economic in not wasting money and doing the right thing, which is in specifying the test cases according to a sound method, which is behind this TDRE. There's just no time today to explain all that, but literature is given on the right side. If you do that, you can also optimize your testing. You don't have too much redundancies if you have a good coverage scheme, and that saves a huge amount of money. Those of you in the OEM domain know that in a safety critical system, you have typically 67% of lifecycle costs related to testing. And I talk not about unit tests, which is part of coding anyway. I talk really about the more heavy tests. Of course, we go into modeling, we go into model in the loop, software in the loop. Nevertheless, we still face a situation that we have a huge amount of testing. And then you do analysis. I do that very often. You analyze the test cases, you look into how testers select their test strategies without all this traceability normally, or not much traceability, and then you know where the money is going. I mean, it's huge redundancies, overlaps, but at the same time also blind spots. And this is what we have to repair, because that's not yet professional. And for that reason, we, of course, work in Vektor also in automatic testing a lot. We work on new ways to create test cases, but at the same time, we should also be aware that, especially for security, it's not, we cannot automate much before we think, and we have to think negative as security engineers. And that's what I want to emphasize in the next part of this presentation. So we have in security implementation and verification a lot of standard techniques in design, like coding rules, static analysis, crypto, etc. We have V&V methods like coverage, like different testing strategies. And of course, we have to test for the unknown. That's the message. And if we simplify the picture a little bit, what you can see on the right side here, these are the typical major test activities from a security perspective, which is on the lower level, code analysis, MCDC, etc. That's on the implementation level. Then we go to the integration, to the component level. We have fuzzing with the interfaces. And we finally also have the pen test. All of those, of course, be also part of a decent regression strategy. And if you look at the different methods and tools, which I try to somehow summarize on the left side, and you see there's quite a lot of knowledge in security testing. And I will jump a little bit into that. We see here tools which we use primarily in the upper level of testing, like a Metasploit is certainly something all of you are using because it's the one dominant pen test tool. But of course, all of you also know that a tool is never enough. I mean, you need a variety of tools. You have to use different methods and tools. And that is why we have this huge table here, because there's never one or two things which would be satisfiable. Same for the methods, which you see in that table. I mean, each of these techniques have their areas where they have a strong effect and somewhere they have a less good effect. And this is where, and I zoom now further in, we come into pen test. And why do we talk here about gray box pen test? That was because we realized a black box pen test, which is the classic IT pen test, is good, useful, and absolutely necessary. You have to attack the system from the outside. At the same time, we should also, as much as possible, use knowledge about content. And that's what we learned with our customers, where we do since many years such pen test projects, that they would, of course, not give us, from the pentest perspective, all the implementation details, because they want us to approach pentest like a hacker would do. But hackers are not ignorant. I mean, hackers go to the internet, hackers go and know exactly what are the frames in the CAN-FD, what would be the attack scheme in FlexRay, and what kind of tools to use for IP. I mean, we have to use all this knowledge which is around with the classic attackers in order to make our test effective and efficient. And this is why we use the gray box, which is we analyze the system, we guess a lot of the things, because I mean, being automotive networking and ECU experts here in Vektor, we know a lot about what is inside, but we assume also any attacker would know, and at least have the potential to know, because these guys have infinite time. They network amongst each other in the darknet quite heavily. And so we have to assume they know all these things. And we cannot just be as ignorant and saying, well, we do the classic IT black box pen test. That's not enough. We have to do black box, and we have to do gray box. And that's the major message of the presentation. Gray box being black box pen test, minus the brute force, because nobody really pays that for brute force. It can be automated, but we should never do it manually. Plus intelligent analysis. We have to focus from a TARA to the assets, to a guessing, if necessary, what would be the internal structure of such a system, into a guessing what would be the vulnerabilities. And we test a lot of infotainment, for instance. And we realized in this infotainment pen test, I mean, independent whether it's a Linux stack or something else, all of those have numerous vulnerabilities, which as an informed software engineer, you can easily guess, and which you have then also to approach, which you would never really approach with black box. And we have done a couple of experiments I will show you later in the case study. So pen testing really brings a couple of methods on top of each other, which mix different test strategies, also relate to different standards, in order to have a systematic approach into how can we approach the EE system, even knowing that the 21434 is certainly not, let's say, the best possible domain of knowledge. It's a good starting point, but of course it still has to grow. If you see the 26.2 of today compared to 10 years ago, we see what journey the 21434 will still have in front of it. Now, PenTest would have 10 steps, which I will briefly indicate along the V, which is labeled in this numbers 1 to 10, which is at the beginning we do a sort of reconnaissance, which means that we try to understand and guess. I repeat this word guessing quite often, because it's exactly what the hacker would also do, is informed guessing about what's inside the system. We then do some structure analysis, not just the interface, but also as much as possible, and trying to understand how could such a system be built, what are the components, what would be the assets? Is it privacy data? Is it functional safety related? Is it maybe IPR? Is it whatever? Then we move over to the specification, which we start to, as much as possible, guess, or if we have it, we of course use it also for the analysis. And from here onwards, we come in the classic TARA, security goals, all these nice things which are described in the 21434, which are normal in security. And now we jump on the right side, because it's now the time to really think in terms of testing. What would be the minimal viable penetration test cases, knowing about the TARA and the assets? What would be the setup of the pen test? What environment, what interfaces, what fuzzing tools, etc. for the pen test? Then we have to think also in terms of key performance indicators, because whatever we are doing, it should be measurable. Test must be measurable. Security must be measurable. It's of not big use if somebody, I've seen reports from highly paid pen test people who would send a report and say, well, we have tested now for, let's say, 10 days because we time box, and it costs you dearly, but the report would not really give much evidence that they ever looked into sound KPIs. And so we have set up a KPI scheme, which we deliver to our customers in order to see about coverage, in order to see about how would different threats and vulnerabilities be addressed, etc. Then we have, back to the left side, derived from that functional security requirement. That's, of course, a consequence not only of step 5, but also on 6, 7, 8. And we finally built a regression strategy. That's all done before we really start the whole systems analysis. And I recommend for those of you who are in design, you think about the 10 steps before you actually do the architecture and detailed design. Now, if we move into what are the typical test activities in PenTest, we have typically 4 major activities, which is interface discovery, network discovery. So we go from the, let's say, we go from the interface to the context. Then we go into the network penetration test. And we go then finally back inwards into the software penetration test. So it's a kind of a inside, outside, inside approach. And what you see on the right side is this typical small scale lab environment for pen test. Obviously, it would look different if it's a more complex setup, but then it becomes also difficult to, let's say, comprehend. So that's now just to give some evidence how such things look like, but I guess you all know it. Now, fuzz testing being part of a good security test strategy should be briefly mentioned. In a nutshell, it's an automatic strategy. That's very important. It needs an external test tool, which is generating test data, which is the fuzz messages. And this would be then sent on the bus, typically just using the existing bus structure. Of course, we might have the need for rest bus simulation for a certain performance load, etc. Back to the system under test, look to the reaction, that's the monitoring of the data, and then create the necessary coverage scheme and, of course, random messages on the bus. And what we then also do is apply all that in reality. We have the combination of fuzzing and gray box, and that is what I want to show briefly in this case study. So the case study looks to a simple structure of a gateway and airbag ECU. We first do the steps which I mentioned earlier, the reconnaissance, the analysis up to the TARA. We use typically Compass, which is the Vektor tool for this different threat and risk analysis. And based on this, we immediately start linking into the pen test cases, the initial pen test cases or the strategy of the pen test. And on that basis, we do a first run, not of a test, but a run in terms of systematic analysis. Do we cover vulnerabilities? Do we cover major assets? Do we cover the priorities from the TARA? And what would be the KPI scheme? That's before we do a single test. This is still part of the setup. On this basis, we move backwards, as I said in this previous picture of V. Then we can really complete on the security analysis, complete also on the pen test strategy, the regression strategy, and from here onwards, we can start the real testing. So it's not just, let's say, a heavy method, it's a systematic method. And it allows also to systematically look also into negative requirements, which would be impossible if we think too much about design or too much about brute force. We need to mix these two things. And in that approach, if we imagine now a set of assets like a specific port or specific signal data, which is inside ECU, such, for instance, that we take this airbag example. Airbag typically would have safety critical functionality, but also would have typically a trigger point for emergency call, etc. So that, the airbag of today is a bit more complex than what it used to be. And of course, also has still links into diagnostics. And that means we have to protect it very carefully. And so we set up this as much as possible gray box strategy from what knowledge do we really have. We then move into the setup of the KPI. Initial KPI are typically test case because time is limited, budget is limited. We also look into the precision. That means the hit rate of specific test case, that we don't have too much redundancies, and we look into the vulnerabilities to also improve effectiveness. Well, that's really what we try to balance: efficiency with precision and effectiveness with the vulnerability focus. That would be now an excerpt from the Compass. On the left side, the right side test mapping is missing here, but we look into the assets, we look into the attack vectors, the threats, and on that we build the test strategy. To zoom in, we can then say, okay, here are a set of assets. like a diagnostic signal, a gateway, etc. We look into attack vectors. We look at the threat level. We take the highest threat level, those which really matter, and from here we generate a specific security goals, and from the security goals we can equally distill then the test cases which we need from a perspective of conducting the testing. And then we run the test case in order to find the vulnerabilities, and typically we find many, so it's kind of it's like a sport event. I mean, people who do security testing are always eager to find things which others might have forgotten to secure. And so we always find some weaknesses, and that is then brought back to the customer, like maybe a root certificate which is not protected, maybe some bus which can easily be attacked. Maybe we succeed with denial of service, a man in the middle. More recently with SAMS, of course, we look very carefully also to any diagnostics interface, because more and more is now running through the OBD, and we have to be very careful that even if OBD is typically rather well protected, it's also a question of how does the distribution of software looks like in a car, how much is it connected to external interfaces, to OTA, what would be the specific gateways and their structure. So knowing about vehicle architecture, we can then also zoom into what could be appropriate test cases. To summarize, we look into security testing always from a risk-oriented perspective that helps to improve the efficiency and the effectiveness. We look into how to approach the hacking as an informed hacker. That is no time-consuming brute force manual black box testing, but always understanding whatever can be tested on a better white box understanding, because we know about architectures, about bus systems, about test tools, the better. And then, of course, we have at the same time also to look at the merge of security and safety. Glad to hear John had said that there will be also some presentations on this intersection, because that's a very important topic. As I mentioned, the bare minimum is to harden your safety goals, because that is certainly for the higher safety and security levels the number one asset to protect. Nevertheless, it's just one perspective. Misuse cases are numerous, and we have to address different perspective. Where do we go from here? We work currently, as I mentioned already, on this merge of MBSE and TDRE, the model-based systems engineering linking into test requirements engineering to make this forward and backward traceability easier, and then also use more and more heuristics to derive from specific architecture patterns directly damage scenarios, but also vulnerabilities. We use, of course, vulnerability databases to retrieve certain information. We want to go in the direction of what I call a security bot, which is machine learning to automatically derive what is the minimum number of test cases for specific vulnerabilities. And we should, of course, also never forget that attackers are motivated by many, many different objectives. And this is maybe the biggest risk from an engineering perspective, that some of us just don't imagine these different dimensions of what motivates an attacker, which is not always just to make harm. Sometimes it's just to show things can be hacked. I had one case that was in railway business, where we had a person who just was obsessed by trying that he wants to control trains in real world, like he was used to control his miniature trains, which are toy trains, which some of you might also have in their house. And I mean, nobody would ever think about this kind of, I don't even have the right attribute of what insane can be exaggerated here, but I mean, the person didn't really want to do harm, he said, and I trust him as a person. I mean, was just overly naive, but at the same time very, very smart. And this combination of very smart engineers and at the same time extremely naive is at least as dangerous as any sophisticated hacker. So you see multiple dimensions of motivation of hackers, and we in the automotive domain have to be very careful when it comes to security. We have to think negative. We have to put ourselves in the perspective of these hackers, and that's exactly why a pen test should always be done by a third party. I mean, even inside Vektor, we follow same rules. If some of our colleagues would make a specific AutoSAR distribution or a specific support for ECUs, they would not do a pen test themselves because that will anyway not work. And we work with them so that we take this independent perspective. And this is what I strongly recommend. Always think in terms of third-party support for these very crucial activities. And it's typically much more efficient also because we typically know where to look and have the background from Vektor and all this networking and testing activities. Finally, one topic, security in design, is clear because of the topics I mentioned along the left side: testing requirements, engineering for cybersecurity, and then downwards to architecture, to vulnerabilities, to hardened architectures like secure boot, like distributed HSM, etc. But also security in test. That was my topic for this webinar, to make sure that when we test, we keep security in mind. We combine the methods which we have in security tests, which are many. As I said, it starts out on the very low level with static analysis, continues into test coverage, goes further on into the function testing, where we also start with negative testing, interface testing, the fuzzing of the interfaces in the individual issue, and later on the whole bus, up to the pen test with its different flavors, as we have seen. And this being said, this is not really a commercial because it's a free event. We are in the same boat here all together. So if you want to join, we have a once per year annual customer event. It's worldwide, it's online on 24th June. We typically start in a late morning Europe time so that also Americans would be able to join. So take a note, and by the way, I guess you will also get this presentation as a PDF afterwards, and then you can also learn more, because we will have, for instance, a security panel. That much I can already tell you. I will not disclose more details, but I can tell you there are experts which you know and which have a lot to tell. And this being said, I thank you very much for listening to this webinar. Hope you take something away for your own security testing, and of course, still a few minutes for addressing some questions.
Okay, so from my side, as first statement, thank you very much for this overview and the insights from the red side of the V model, which is of course also really important. I have one first question. If we have the situation, there is normal development in, or let's say normal development from the look backward in the past in the automotive industry, where we have all these testing purposes, but without focus on security. So then in your presentation, you mentioned there are on the different levels, there are different components with respect to security, which must be done to cover all aspects. But the question is, if someone starts and start with the basic I described at first, what would you recommend to go, let's say, at the first or the first two topics where someone can get the most efficient benefits with respect to security? Is it a fuzz testing, penetration testing, or something else? What is your recommendation to start?
If you remember when you were a kid and you had all this long list of Christmas wish, and your parents would ask you, so which is your top 3 or top 2?
Yes.
I guess that would always be the same answer. I can't really tell you because all of those are relevant, but I got your message. I mean, at the end of the day, we always have a limited budget and time.
And we have to start with something.
Yeah, so I suggest approaching it from 2 angles. On the bottom, I'm a very strong advocate of good code quality. And that means since that is not so much yet understood, start thinking about a decent automatic static analysis, which you can even plug into your Jenkins pipeline. A couple of good rules. It helps a lot because many things which we typically find much later in testing are far too expensive because you could have found them earlier with a static analysis. So that would be on the bottom of the V, my recommendation. But of course not, they are very fancy, expensive tools which give you then zillions of warnings, and this would distract any normal engineer. You have to really spend some effort to focus on a few rules. But if we know that today, like 30 years ago, buffer overflow is the single most relevant C vulnerability, seems to be not much learning taking place. And these are things you can really detect with static analysis. Now, the next one, of course, since I spent so much time now in my presentation, it would be on the upper part, a good pen test strategy, because if you follow, even if it was now just a very short presentation, but if you follow the approach to combine efficiency effectiveness and you do your pen test very well, then you connect it also with the Tara, with your vulnerabilities, and you have a real good top-level perspective, much more than any architect, into what could be weaknesses and how would I address those. And so the short answer would be static analysis with carefully selected rules, which you check automatically, and the mentioned gray box pen test, looking into efficiency and effectiveness bundled by a good analysis combined with Tara.
Mm-hmm. Okay, thanks. I think this was very good answer to the question. The next question, to describe the situation, you spoke about efficiency, which is really very important. But on the other hand, at least from project management side or something like that, they want to know also when we have fully covered everything what we have to take care in the project, for example. I know this is a little bit hard to say in the respect for security. So with the older development-driven test approaches, there is, for example, the topic to have all the requirements covered by test criteria, for example, or something like that. But if you look to security again, do you have a recommendation when we can say at least, okay, we can say with a good feeling in this project we have done what we should do in respect to security, or in other words, when we have covered everything, so that we can say, okay, this we can have a good feeling to bring this product in the market from testing perspective, of course.
Yeah, I was a bit smiling when you talk about this fully covered, because that's a word which I really almost hate, because
sure, I can agree.
You never have really the guts to do that, and it's impossible in practice. What we, by the way, and this is also important just to mention right away, security is not just because you test a lot. I mean, we still have security by design, and that means not only following coding rules, but it also means to make robust architectures. That's something which I didn't talk about because I cannot cure the world in 45 minutes, but that's a very key topic, to not just try to improve security after the facts. The more we think in terms of robustness, in terms of recovery, in terms of graceful degradation, if you want, that helps also a lot, because we are never really in a situation we can say we have fully covered all test cases. So it's always a balancing left side, right side of the V. But again, back to your question, that's exactly why we use this KPI or this dashboard, where we look on the one side into, did we, for instance, have a good coverage of the vulnerabilities with our test cases? That's a very important optimization scheme. So we typically make a sort of a wheel, like a pie diagram, where we look into the vulnerabilities and look how much % of our hits really go into each of these vulnerability. At the same time, we look into coverage from a perspective of requirements correlation, especially with the negative requirements. So that gives you a coverage scheme in terms of effectiveness. And thirdly, in this dashboard, of course, to again and again ensure that whatever you can automate, you do. So the test setup, which we use also here in Vektor, is quite extensive with respect to automation, because of course any test case which you can automate saves human labor, and that's of course an asset, especially if you talk about regression. Because one thing I also didn't really mention much, and we should at least spend a minute, is that the more we go into more frequent deployments of code and software to vehicles, the more we have to repeat all that automatically, because not only because we want to make sure that we deploy good software, but even a small change done under pressure can cause lots of defects. We all know that from our traditional IT patches. I mean, the more you do under pressure, the more errors. And often we have seen in our operating systems on our desktops, a patch is followed by 2 other patches, because the first one might have done his initial functionality, but create a lot of security vulnerabilities. So that's also important that we automate.
Yeah, I totally agree. And of course, you mentioned it also during your presentation, the results of a threat analysis will be also a good indicator, I think, for build test cases on it, based on it.
That's actually our starting point, as I explained with these 10 steps. It's one important starting point to identify, let's say, a coverage scheme, a traceability scheme from a perspective of the assets and threats. Yep.
Yeah. And related to this, of course, the quality of the threat analysis is also very important.
Very, very true. Often it's done superficially. Often it's a copy-paste exercise. Often we realize that the prioritization is not done well, which is, by the way, not easy, because all these methods like Evita, etc., haven't, which initially brought up the scheme and now made it into the 21434, still have to be digested. But it was pretty similar 15 years ago when the first time all this ASIL mapping was coming around. I mean, the first 10 years, companies were struggling really how to do that in a repeatable way and not overdo. And I see the same, of course, now. It's always a kind of balancing, doing the right thing, but not doing too much. And that's why I say you have to look to efficiency and effectiveness as an engineer, not just on one of the two.
Yeah, I absolutely agree. So I checked again the question from the audience, but there is, so far I see nothing open anymore. So we covered the questions, and I would say you explained your topic very well, so that it seems no additional questions are open. And that's why I would say we can close for today. At first, to the participants, thank you for the participation. And to Christof, again, thank you for this great presentation. There comes also via the chat just some live feedback that the quality of the presentation was very well, and the audience liked it very well. So thank you for that. And then I will give you the possibility to provide some last words before we close.
Yeah, I also thank to the attendees, because I mean, this is always work in progress. I mean, none of us is a professional presenter. We show what we know, and I mean, this is normal for engineers. We try to condense And I should very clearly say this presentation is the result of a lot of colleagues of mine with whom I work very closely and who are very smart and bring new insight. I mean, if I just think about this 10-step models and how much effort we put into it, I mean, these are not things which I create. So I would like to thank all of those who, especially also our customers, by the way, because without working with different companies, you will never learn, because I mean, you learn from errors. That's also unfortunate, but this is engineering.
We are still live, or? Okay, so then I would like to close the meeting for today. Again, very thank you for the participation, and I hope also you liked the presentation, and we see us back in one of our